Okay, a little bit on lunar missions. There is a program that NASA had called the VIPER, and it stands for Volatiles Investigating Polar Exploration Rover. It's a rover meant to go to the moon to look for deposits of ice. And that's actually pretty important because if you have ice, you have water. If it's in large quantities, you can fairly easily melt it. Of course, you can use that for drinking, but more importantly, also, you can generate hydrogen and oxygen by electrolyzing it. You can also make rocket fuel out of that. At least you can certainly make the oxidizer parts, the oxygen, pretty easily. There's kind of a race going on for resources on the moon, China being the main participant at this point. So prospecting is kind of a key part of that. That's what this is really about, is figuring out what's going on. Now, there's scientific value as well, just figuring out, what is really there, how did the moon form, and all this kind of thing. But when you get down to it, it's kind of an economic issue. Where is a good place to put a base where you can actually start to use these resources for your own survival as well as an economic benefit? And actually, in particular, it was also stated that it would help in site selection. When you're going to have your crewed landing, you want to pick a place where, of course, there's going to be some of these resources. And then longer term, where do you put permanent bases? Again, you want to have access to resources so that you can survive and possibly have economic benefit. So what are some of the challenges? Well, this is sort of different because the plan here is actually go ahead and drive right into the dark craters. No one's ever done this before. I mean, everything has kind of been on the surface. They actually want to go in. They're saying the really cold spots on the moon where the ice could survive would be the dark craters that are permanently dark. There's a lot of those, especially at the poles, because the sun comes in kind of horizontally, and as a result, they're eternally dark. You got to drive into them to see what's there. We don't have any data on that. And they were going to take in spectrometers for doing analysis, mainly looking for water is the main thing. They were going to look, of course, what's on the surface in those craters, but also drill in a meter, 3 feet, and get a feel for what's underneath. Then they would drill, that would kind of bring up pieces so they could really see material that was present all the way from the surface all the way down. And you say, well, okay, this is great. We've done rovers. This should be a piece of cake, right? Well, we've done rovers on Mars, and it turns out actually it's probably tougher on the moon for a whole variety of reasons. One is the temperature variations are much, much greater, 500 to 600 degrees Fahrenheit. And I put a range in there because it depends on exactly where you're talking about. But you figure the hottest it gets is maybe, 250, 240 degrees Fahrenheit during the daytime. At night, and if you're down in a crater, people are saying it gets as cold as 400 degrees Fahrenheit, minus 400 degrees, which is only 60 degrees above absolute zero. So that's a whole lot worse than Mars. Mars, you have more of an atmosphere and wind and that sort of thing, and it tends to equalize temperatures a lot more. This is a much more drastic variation. You have to design the system to handle all that. You got to keep cool, so they build all kinds of heat pipes and things into it that you don't necessarily put in other places. You have a whole lot more insulation, just basically to mitigate all the temperature extremes. At the poles where you're going to be here, also the shadows are very deep and they're very fast moving. Now, the other thing is that typically when you're designing for the moon, you have to deal with the really long nights. It's a 28-day cycle, so you typically have 14 Earth days for a day and 14 Earth days for a night. And of course, you got to survive all that. That's pretty hard to do. That makes it much tougher on the moon. Now, it's kind of a little different at the poles, though. Down at the poles, actually, if you're up at a high elevation, you have access to the sun during the lunar summer. It's only maybe 4 Earth days that you're actually out of the sun. And so they have to design a mission that the rover can also climb up to the high spots during the long nights, because this is not powered by any kind of radioisotope generator like a lot of the long-lasting rovers are. It's still just solar powered. And so they have to be able to go out and bask in the sun, essentially, to keep warm and to not have to last so long. Another problem is they can't really be quite sure what the terrain really is like there. There could be areas where there's a lot of really soft dirt or really hard terrain, especially when you get down into these craters. They don't really know what it's going to be like. So they made the wheels much more versatile. They essentially can lift up and down and rotate around quite a bit more so they can kind of walk if they have to. If the wheel gets stuck, they can kind of lift it up and they can almost do kind of a slow walk with the thing. They can turn on their own radius, which is a little tighter than, let's say, the Martian rovers have been able to do. They can spin in a circle. They can drive sideways while facing the same direction, all this sort of stuff. So they end up with a golf cart-sized rover, solar powered. It has headlights. Never had headlights on a rover before. Never needed it because they weren't going down into craters. And it must have a really big battery because it still has to last for 4 nights. it has to last while you're going down into those craters, and you don't have any solar power either. So it's kind of an interesting, very impressive technology demonstration, really. It cost about $450 million to build. This is quite a bit more than the typical project that was done as part of the commercial lunar activities that NASA's been doing. Anyway, it's built, and it's sitting at Johnson Space Center right now, waiting for testing. It's been built, some testing that has been done, but more is needed. It was going to be delivered on the Griffin lander, which this is the product of Astrobotic. Remember, Astrobotic's first lander didn't make it. They failed along the way with a valve problem. The Griffin lander is quite a bit bigger, so this is a brand new one. And people have criticized NASA for putting a very expensive rover like this on an unproven commercial platform. But anyway, both VIPER, for various reasons, and Griffin, both of them were delayed and were scheduled for 2025. So that's the current plan. However, NASA killed it. They are actually having budget limits. And on July 17th, they announced they were killing VIPER. And what happened was they said, well, it looks like when you throw in the cost of testing, it was only an additional 80 million or so, but it would have gone past 130% of the original budget. That automatically triggers a termination review. And so at that point, that means you got to do a lot of analysis. You probably have to report back to Congress and get special funding and all that. So NASA has a decision to make. Is it worth fighting for this or is it not? And they decided not. Now, strictly into opinion here, this is not fact, but from past behavior, it's pretty clear NASA, they want to focus on science and exploration footprints kind of things. They're not interested in things that are more supporting the space economy, like development of a space economy, or even a sustained lunar surface presence. That's just not their thing, and they pretty much said that. So there are people that are doing all this, but the big bucks are still going for the Moon to Mars program, which this is actually nominally a part of, but when it gets down to what gets cut, this is something that's more oriented towards sustainable operations on the moon. They're not that interested in it. They made it especially obvious. That was July 17th. They said, okay, if you have an alternate proposal for what to do with this thing by August 1st, let us know and, we'll consider it. So they gave people 2 weeks to figure out a solution. That's not really enough time for any serious engineering. By the way, this does repeat past history. There was a similar mission 6 years ago that was also killed. And that was actually announced the day that a new NASA administrator was coming. They decided to kind of close out his options. They just said, okay, we're going to kill this thing. And it was actually the same kind of thing. They said they're going to take it apart right away, and we'll reuse those parts on the next mission. So we're kind of just repeating history here. So what are they going to do? The plan is that 950 pounds that the rover weighs, they're going to send just dead weight, a hunk of metal or something. Now, that's the plan, because you do want to demonstrate that the Griffin lander will work. I mean, that is also a NASA-funded project, so that's not completely crazy. However, you might say, well, why not just put the VIPER as it is on there? I mean, what do you have to lose? But actually, Astrobotic is free to come up with other uses for this. NASA said, you can do what you want with it, apparently. So they have other projects for putting stuff on the moon, in particular for setting up a grid of solar power on the South Pole, where they put up solar panels way up high where they can easily get access to the sun. And they may do something with that. The problem is it's a short period of time. I mean, if they're going to launch it in 2025, to suddenly shift gears and get all this going, don't know if they can do that. So it's not clear what will happen. Okay, now on the other hand, it's sad, a comparison here. China has just finished returning from the far side of the moon. They took samples on the far side of the moon, communicated by a satellite they put up there, brought the samples back to Earth, dropped it in Mongolia, and we haven't seen too much on the results of that, and you probably won't for a while. That was a 53-day mission. We've reported on it before, but now it's actually complete. The last time we talked about this, the samples were on their way back. They just lifted off the moon, and now they're back. They got about 2 kilograms of dirt from the surface and rocks, and also the subsurface samples, they also had a 1-meter drill, so they're going to have a lot of samples. I saw a report that I'm not sure is true or not, but someone said they found a lot more hydrates, meaning a rock that you can easily get water from. It's got the hydrogen and the oxygen. I'm not sure how credible that was. Usually it's going to be a couple of years before you get significant results back from these kind of things. Okay, so while we're at it, there's time for an update, I think, on some of the Chinese space programs. So we've talked about this Chinese lunar exploration program, actually in quite a bit of depth in one of our earlier meetings. And this particular lander with the sample return mission, that was part of that. We've done that. And of course, there's other programs we've also talked about, like the space station. They have other ones like their Mars probe and some of the military uses, and even a planetary defense kind of a mission, kind of like our DART mission. But what I'm going to talk about here today is satellite megaconstellations, meaning things like Starlink, where you put up thousands and thousands of satellites. And that is one of their plans, to integrate broadband internet with navigation and monitoring, military uses, and so on. They have an official national plan for this, integrating it all into one system. And they pretty directly copied Starlink. That's pretty clear. After all, it works. You don't even have to actually have any spying. There's enough published, knowing that you can do these things, knowing that you can build the satellites, you can do communication links. That's probably enough, So they're going to build that. They also explicitly highlighted that Starlink is very important for military use. And so they've highlighted that. They cite the Ukrainian example, saying they really need to have much more capability that they control. So we're talking about putting up thousands and thousands of satellites, just like Starlink. That would dwarf their current number of satellites, which is about 800 or so. Anyway, they want to have a commercial space ecosystem by 2025. Now, this won't be complete by any stretch of the imagination, but it should be up and functioning to some extent. There's two major constellations going up. One's called Chang'e, or I'm not sure I got the pronunciation right. It translates to 1,000 sails is the name of it. And that's going to be about 14,000 satellites ultimately. But the launch has just started. I'll cover that next. The second one, Guowang, is called the National Net, and it's another one with 13,000 satellites that should start launching this year, later this year. That's the plan. Now, there's some others that may or may not happen. The people that built the first rocket that used methane and oxygen and got to orbit with it, they own this other company called Chang'e Technology. They filed applications to build another 10,000 satellite constellation. ITU is the International Telecommunications Union. They're kind of a gatekeeper. Well, basically, the organizations that monitor any kind of telecommunications are kind of the gatekeepers for the satellite communications networks. And Huawei also wants to do its own constellation. So anyway, the 1,000 sails one has started. August 6th, they launched the first 18 of their satellites. They raised about $1 billion to construct it. So these are all nominally private companies, but they're all kind of ultimately controlled and owned by the state. So, but at least they are listed as separate companies. One bad thing that really happened here is that they had a lot of debris generation from this launch. The second stage just kind of broke up. And that's even right in the orbital plane that their satellites are in. So it's almost an immediate threat even to them. 700 pieces is not pretty. It's raising concerns that if this is just one launch of 18 satellites, when they have thousands of them up there, are we going to have more problems like this? Now, their plan has to be that they're going to use different rockets to do this. This Long March 6A, this has been around at least 10 years. The 6A version has solid boosters. It's really not that big a launcher. They add solid boosters on the side, and they can get it up there. But it's the second stage that's breaking up, and it's happened before. The last couple of launches, actually, they've had this kind of problem. So apparently, we don't know why, but for whatever reasons, when they use these, they have them. So we think they're probably going to be replacing, and using different rockets going forward, because even for their own satellite constellations, they can't afford to have this much debris around. So their plan is 100 satellites for this year, 648 by the end of next year, and 1,296 in the first phase, which is within a few years anyway. The satellites themselves look a lot like the Starlink version 1. If you look at those, if you remember what they looked like, there was the body of the satellite, and then there was a solar panel on one side. It wasn't symmetrical like a lot of satellites had been. It looks just like that. They stored them for launching. They store them in flat packs, just like Starlink did. They are up at a higher orbit, though, 500 miles versus 340. The Chinese know they have a problem. They need to get the launch costs down. So they're going to also be making a whole lot more launchers that are reusable to actually start competing with the Falcon 9. And I've listed 4 of them here. Land space is probably going to be the first. They can handle a payload comparable to what the Falcon 9 can do. Their version 2 is not reusable, but version 3 will be. Also, like their version 2 is going to be based on methane and liquid oxygen. And there's several others that are smaller, but probably those first 2 are the most likely ones to be used. So any questions, comments? Okay, that's it. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.